Hello, today I'll be showing you how to solve heat conduction equations within a wire. So in the example that I'm going to show you, we have a resistive wire that is used for boiling water. It is submerged within water. We are given H, the surrounding temperature of the water, and the radius of the wire itself. So in order to start, we use the heat conduction equation. And then we can simplify it because we are in steady state. We have a constant K, and we are using cylindrical coordinates. The heat conduction equation is shown up top, and it is simplified with those three to the bottom equation. Next, we apply our boundary conditions. We have two boundary conditions of convection and symmetry. Then we go to the temperature distribution. So this is how we have actually solved the equation. So the temperature is equal to the surface temperature plus the heat generation of the center, at the center of the radius, over 4K, minus the heat generation multiplied by whichever radius you're at, divided by 4K. The surface temperature is defined as the heat transfer times R0 over 2H plus the surrounding temperature. In this case specifically, the surrounding temperature is 100 degrees Celsius. Using these equations to solve for the temperature at the center, we get that the temperature at the center is 125.1 degrees Celsius. The temperature distribution is also seen on the graph on the right hand side. Now, this is how different parameters change the temperature distribution. So as we can see that with the change in radius, as the radius increases, the temperature increases as well, but the rate of that, or I should say, the equation that is found from the distribution of the temperatures remains relatively constant, but the temperatures themselves rise up a lot more. Now for heat generation and thermal conductivity, changing those, it doesn't seem like it makes that big of a difference because they all converge to the same point, and it doesn't matter for the most part, but until you get to high enough temperatures where you could start to see material failure within the actual center of the wire due to the amount of heat that is present within it. So it does need to be regulated, but lesser so than the actual radius of the wire itself. So if I were to redesign it, I would maximize the radius as much as possible in order to maximize the amount of heat that is off of it. The heat generation I wouldn't really change because it doesn't affect the outer temperature, but if you allow it to rise too much, it can cause failure within the wire. And the same goes for thermal conductivity, is that I personally would not change it because it doesn't affect the outer radius, or the outer temperature I should say. But once again, it can affect the wire itself if you do not regulate it at all. So in this, I have shown you how to use the heat conduction equation, boundary conditions, and then using those two to put together an equation to see the temperature distribution over the course of this wire. Thank you for listening.